What's going on, everyone? In this video, I'm going to be breaking down the pattern over the next 2 weeks. A warm, mild pattern is likely for most of the U.S. until about New Year's, where the pattern flips to cold. So I'll break all that down. So the first thing we want to look at when we talk about our pattern flip to warm and then back to cold is a Pacific jet stream. So this is our North Pacific jet stream. And when it's extended to the continental U.S., it floods the North America, really the entirety of North America, with mild Pacific air. And that's what's going to happen. So you see this Pacific jet, it's very strong. You can see 200 knots in the central Pacific. It extends all the way to the U.S., western U.S., and it's flooding the that frame load, flooding the continental U.S. with a milder Pacific air. Some parts of the east, thanks to cold air damming, are still below normal, but for the most part, everyone is above normal, except for a select few areas. This continues really until I would say New Year's, is when the Pacific jet retracts, New Year's Eve. You can see the Pacific jet is much weaker. It's still strong, but it's much weaker, and it's retracting. It's not past this line. And after this, we really don't get a Pacific jet extension. It actually retracts back to near the date line. You can see it's still strong, but it's retracting. So it's not flooding the U.S. with mild Pacific air. This is important because it allows for Arctic air to come on down from the high latitudes. So we have this Pacific jet retraction. That isn't the Pacific jet. That's the other. That's a polar jet. It's polar/subtropical jet. I can't tell from this, but that's not the Pacific jet. So yeah, Pacific jet retraction, and that allows for colder than average conditions to return. So that's Pacific jet stream. Now we take a look at our 500 millibar chart on the GFS. What's really driving this strength in Pacific jet stream is this positive EPO. You can see a dip in the jet stream near Alaska. This force is ridging across most of the continental U.S. A bit of a trough of low pressure in the northwestern U.S., but other than that, it's mostly higher pressure, higher heights, leading to more ridging in the U.S. So eventually that will break down, right? Eventually we'll get our jet retraction in the North Pacific. You start to get returning to more of a neutral to slightly negative EPO. But what's more important here is this west-based NAO, negative NAO, starting to develop. So we have this Greenland block starting to develop. And what's that going to do is that's going to eventually force, it's going to take a little bit of time, but it's going to force a cold air dump into the continental U.S. And along with this ridge, this Montana ridge, this positive PNA, it's going to spike up into Western Canada. You can have a storm opportunity around the 4th or the 5th. Because of this negative NAO, it's a decaying negative NAO, 50-50 low. So I'll draw it out. We have this ridge in Greenland that's going to help pump warm air up into Greenland and force Arctic air down. That we have a pumping ridge in the west. It's going to force even more Arctic air down. So we have this Arctic air, not Arctic air, but cold air coming in, and we have our 50-50 low pressure starting to develop right there. So all of that is going to help us get a system. The problem is this trough axis is too far west. And basically what that means is it's too far east. The trough axis is too far east. Basically what that means is it would favor something out to sea like this. You can see this is our system here, low pressure. And it goes out to sea. It doesn't really impact too many areas. That's the biggest problem. The axis is like, I can't really draw it, but it's like that. I can't draw it. But it is too far east. I want to say it's too far east. And that would tend to encourage an out to sea system, not cutter. I don't think cutting is a problem with this. It's out to sea. But that's our first storm threat. When you have that positive PNA, you sort of lose it, but you do get that positive PNA and negative NAO combination along with a 50-50 low. Now, a concerning trend that I'm starting to see is the GFS and other models losing this negative NAO. It does return. I'll spoil that. It does return on this model, but you don't really want to lose this negative NAO. This is going to mean that storm opportunities are much less, probably only transient clippers would happen. So 1 to 3 type events, nothing over 4 inches, unless you're like in the lake effect or in the mountains. So if you're in the lake effect area, you'll see in the mountains. Now, because we have this strong negative EPO, we finally get that strong negative EPO to develop. You're still going to get cold air dumps in the eastern U.S. because you have this high latitude blocking that's forcing cold air downward. So you do get these cold air dumps, a bit of a positive PNA here too. And this is our fantasy run, fantasy snow. I'll show it later, but it's not going to happen for several reasons. One, it's a GFS 3 through 40 hours out. Even if the Euro does agree, which actually it does, surprisingly, it's still highly doubtful. A positive NIL. You do have a bit of a 50-50 low, which is like low pressure right here, I would say. Maybe slightly further south, maybe like right there. But it decays, and when the storm comes, there's not really no 50-50 low. It just doesn't make sense. You do have this positive PNA out here that would assist in allowing the storm to dig and not cut, but it just seems highly unlikely, even with the heights. I'm obviously not going to believe the GFS, even if the heights make sense, but no negative NIL and producing 6+ inch storm anywhere seems non-interior, I should say, non-interior 6+ inch snowstorm seems highly unlikely to me. But what happens towards the end of the run is it's kind of an odd setup. You have this positive NAO that's trying to develop. We still have this negative EPO. Storm system trying to move on short of the Pacific Northwest. If I had to guess, this is a recipe for more cold air dumps into the eastern U.S., but I don't know. It's kind of an odd end to the run. Bit of a ridge trying to build in the southwestern U.S. We'll have to see what happens. So that's our heights. Now, if we take a look at our 2-meter temperature anomalies, you can see warmth dominating. Now, we do have a bit of cold trying to hang on the East Coast, but eventually the warmth will run out. It's going to take a while. It's going to get much longer than it took the rest of the country, and far above normal temperatures here in south central Canada. But eventually that cold will run out, or the warmth will run out, I should say, and we'll start to get a blowtorch of a pattern up until the New Year's. I mean, there's really no other way to put it. You start to see the cold air returning. Eventually, that'll be forced south and east. But for now, a torch of a pattern. And the first cold air dump is in the western Canada specifically, but also northwest. This is likely to be very transient. There's not much to say that there's a persistent western trough coming. No models really show the PNA going negative, and you don't usually have a negative EPO and a negative NAO and a negative PNA. That's kind of unusual. So I would definitely favor a persistent western trough, but a brief cool down is not unlikely, especially in western Canada. So the first cool down comes western focused. Then we start to get a cold blast, and this one's focused in the southeast. So the first one will likely be focused mostly southeast, right here. So these spots right here will likely see temperatures, sorry, 15 to 10 degrees below average, some 20 degrees below average mixed in there. I wouldn't pay attention to where exactly those are. I'm not going to say that southern Alabama and southern Mississippi are going to see 20-degree below average temperatures, but if you're in the southeast, that's definitely something to watch. So now, if we take a look at the progression of this, we get this warm air trying to intrude into the east, but it's very transient. It lasts less than a day, really only 12 hours. And then you have the double high latitude block, not double high latitude block, but favorable teleconnections like a negative NAO, for example, on a Pacific jet retraction. It's very hard to get persistent warmth, so very quick warm shot. And then look at this, we have more Arctic air on its way. I don't know if I buy this much cold out west, especially if it's trying to bring cold east. But either way, we get another shot of Arctic air to come in. to come in. I don't know what's happening to me, but yeah, multiple shots of Arctic air that come in and we're living in chilly conditions. I mean, this is the coldest time of the year climatologically, mid-January. So we talk about these temperatures, 20 degrees below average. It's quite serious, even for the deep south. That came in temperatures in the teens. So yeah, a pretty significant Arctic blast to end the Mahler run, and then finally get that warmth to build out west, which is something I expected, and that would likely mean more cold air is on its way. So, um, yeah, you know, a couple of cool downs, maybe some transient warmth in between, but mostly colder than average according to the GFS model. Now, um, obviously the GFS model comes to precipitation, especially plus 300 hours, take with a grain of salt. Even take the temperature map with a grain of salt after right here, especially this Arctic air intrusion, especially with this much cold air out west. Listen, the pattern is definitely cold there. This isn't crazy. This isn't crazy stuff from the GFS. I've seen it do crazier things, but it just I would press caution on anything past here, really. Anyway, this is the precipitation map, and we see here low pressure in the Pacific Northwest is our atmospheric river, I believe. Sorry, it keeps going back to the last frame. Atmospheric river, mountain snow, coastal rain, usual arrangement. This is our potential severe weather event. You can see unfolding right now, I believe. But yeah, that's our severe weather event. That's going to move on out, and potential for some more severe weather on Sunday, right into early Dixie Alley. Potentially, we'll have to see. Now, in terms of non-severe threat, it's just going to be rain. There's a lot of warm air being pushed ahead of the system. You do have some icing concerns in interior New England, but other than that, a lot of warm air being pushed into the system, pumped from the warm Atlantic, warm Gulf. It's not too big of an arrow, but you can see what I'm pointing at. So even rain for the mountains, even rain for interior New England, potential for some icing to mix in the high elevations of Maine, but really not that much. And then maybe some back end lakes if you're in Canada, but a lot of warm air injected over this system. Then we get this New Year's Eve system, potential for some snow and rain showers in potential for some rain/snow in northern Illinois, Chicago. We'll see that materializes. But overall, mostly a rain threat. Again, also a bit of snow in Nebraska, Iowa, but it cuts, and there's not even cold air in place before it cuts. So, even like again, even the mountains, Appalachia getting rain, in areas of upstate New York getting rain. It's bad drawing, but storm cuts and it draws a lot of mild air up from the Atlantic and the Gulf. So yeah, a lot of rain, much too warm for any snow. And again, maybe some flakes, maybe some accumulation in the higher terrain of Maine and Vermont and New Hampshire. Wouldn't shock me. And now you have this I don't even know what to think of this system. You have this Gulf system, I guess, southern slider. You could call it something like a southern slider. Kind of comes up, and it you look at this and you think it's a good system for the south, but it absolutely is not. We'll have to get rid of that. If you look at the temperatures, they're not even below freezing. I mean, I can go to the mid Atlantic. Temperatures are in the mid to upper 30s with this system. Maybe areas north and west are in the 32. South here in Virginia, North Carolina, in the mid to upper 30s. So this is a snow event because 850 temperatures and 925 temperatures are below freezing. But if surface temperatures in the mid 30s, that's not going to matter. So this looks good on paper. It's probably not going to happen. Flow is much too progressive. Um, what that means is when it says flow is much too progressive, that means storms don't have time to form. And I doubt this. I really doubt this. Even if this did happen, it would be a non-accumulating snow event, or it'd be a snow event that only where it only accumulates on grass. Where there's only dustings on grass, wherever the heaviest band's set up. So don't even pay attention to that. To be honest with you, we get more precipitation, Pacific Northwest again, coastal rain, mountain snow. Um, this is a potential for storm threat. It forms out to sea. We'll have to see what happens with it. You can see this. Put it back. This area of moisture right here. It forms out to sea mainly, but we'll have to see what happens with it. I don't have too much faith in it. We'll go back a little bit. Don't have too much faith, but there's a probably of this huge dip in the jet stream, pounding the east with cold air. And then we get this low pressure to kind of move on through this fast moving clipper, maybe bringing a dusting through like northern Michigan, northern Wisconsin, northern Illinois. Not doing much. Uh, now we're getting into the crazy GFS stuff. Really don't believe any of this. There's signals for this stuff. It's possible given the cold air that's in place, but at this point, it's GFS crazy talk. First GFS crazy is a snowstorm for all of Arkansas and northern Mississippi, northern Alabama. This isn't like a that's crazy. It's been shown as a signal on periodic model runs. I don't believe it, but there is cold air in place, and um, you know, northern Alabama, Arkansas do tend to get a couple of accumulating snow events in January, especially. So it's not unheard of. This isn't like showing snow in northern Florida, but it's GFS fantasy, whatever. Um, it's pretty dry for January 8th, and then we get this coastal low to develop nor'easter type event. Major snow for 95. Again, this doesn't make sense to me because there's no NIO block. There's no 50-50 low. So I don't know where it's getting this from. In reality, this storm probably can't form, or it's out to sea. Those are that's the. I'm telling you the reality. I would like for this to verify, but if the height map verified, and it's much more likely the height map verifies than this verifies, we are not getting this system. So it's nice to look at. Even brings snow to, I believe, the northern Atlanta suburbs, or maybe that's even Atlanta. And there's really no mixing, especially unless you're like really, really close to the coast of Carolina. But it brings a significant amount of snow. But I don't believe it. It's also the GFS 300 plus hours, so that's not trustworthy either. Then we get this clipper system to move through, and snow showers, and afterwards another rain and snow event pounding the Pacific Northwest. High pressure builds in the east, cold and dry to end the run. Sorry, I have a really bad cough. Anyway, so European model. So the European model, very similar to the GFS when we started out. Positive EPO. That decays into a sort of a negative EPO, I want to say. The ridge is much more pronounced in the high latitudes or the higher heights, less pronounced in the lower latitudes, but definitely negative EPO develops. Negative NAO also develops. This is our first cool down. We also have this positive PNA. So the recipe for East Coast cooldowns, as per usual, negative NAO, positive PNA, or always gonna get some sort of cold shot in the east. And that's pretty much what happens. Very similar to the GFS. Nothing too crazy. We start to develop this positive EPO. This could be a bit of a concern that's been shown on models is developing that positive EPO. I'm not too concerned about it, especially because we have this Greenland block in place and also positive PNA. But it is something to watch for sure if you're looking at potentially the models overdoing the cold, which I don't think is happening, but something to watch. Anyway, unlike the GFS, and this is very interesting, it hangs the negative NAO around. So you get this persistent negative NAO in this model. You watch up here, Greenland block, fairly persistent. And what that's going to allow us is that's going to allow for a lot of cold air dumps into the eastern U.S. See this one cold air dump, this cold air dump, this cold air dump, and this storm system that is also probably fantasy. So yeah, a lot of cold air dumps into the eastern U.S. thanks to this negative NAO, and you can visually see it. All of these cold air dumps start roughly right here, and they just travel eastward, or not eastward, south and eastward. That one starts in Alaska because of that negative EPO, but you can see cold air dump, thanks to this negative NAO. Also, it's being assisted by a positive PNA out west, so this ridge out west, ridge here, forcing that cold air southward. Model run ends with a positive EPO, negative NAO. I don't like. I would like to say that this means a Pacific Jet extension, just like the GFS model. But again, when you have a negative NAO in place, it's gonna be hard to get a lot of warm air into the east. But it could warm up a bit. So that's our height map. We see with the 2-meter temperature anomalies. Sorry, I stepped a little there. 2-meter temperature anomalies. It's the end of the run. We see here with 0 hours out. Very similar to the GFS. It's not going to be any different. Again, cold air hangs on dear life in the east. Warm everywhere else. Eventually, that warmth wins out. We start to get a torch of a pattern. First cold air dump is out west, but it's very transient. It's even less transient. It's even more transient than the GFS. Immediately builds that warmth back out west. So I don't want that anymore. And we start to get pretty significant cold shots into the east, south and east mainly at first. Again, this looks like a warm blast, but it's very transient. It weakens a lot, especially as it gets near the coast. So a very weak, transient warm blast, and then we get more cold air, Arctic air on its way. Maybe another very weak, lasts like 6 hours, another potential warm up, but a very cold Arctic-y pattern, Arctic-y, doesn't really make any sense, pattern coming up for the east. A lot of warmth out west and a lot of cold in the east is the pattern, at least according to the European model. Now, what concerns me here is this warmth potentially trying to push eastward. This is the potential for the Pacific Jet to kind of flex its muscles. We'll have to see though if that warmth extends eastward. You can kind of see it starting to do so, and as that cold moves out, it's speculative, but I wouldn't count that off. I wouldn't count that as a zero possibility. Whatever. But that's the European model temperature forecast. Now, if we take a look at the precipitation type rate, again, we have our warm air injected ahead of the system. Sorry. Warm air injected, so not really much frozen precipitation to speak of. Again, possible some flakes missing in western Michigan according to this model, but a lot of warm air ejected out of the system. Maybe some flakes mixing in Appalachia, but not in the snow really isn't a threat with this one. Same with this one, unless you're in really Illinois or Iowa or Nebraska. Snow again. I mean, snow isn't a threat unless you're in those states. And also, um, uh, if you're in like the interior northeast or high elevation, you could see flakes mix in, but also wouldn't expect too much in the way of accumulation. Maybe some snow showers mixed in Ohio, Indiana, Appalachia. But it's much more aggressive than the GFS in terms of the amount of cold air that's available. And you get this like kind of after snow showers. Looks like a lake effect event actually. So lake effect areas, lake effect snow showers potentially for the Great Lakes region. We'll have to see what happens. Anyway, we get this clipper system to move through. Could bring some rain, some snow showers. Depending on where you are, coastal might see snow showers. Coastal might see rain showers, I should say. Coastal's not going to see snow. If coastal see snow, then interior for sure see snow. But maybe coastal will see snow. Interior, I keep messing that up. Coastal will see rain. Interior will see snow. We'll have to see though. We'll have to see. But yeah, quick transient clipper either way. This system forms just out to sea. We'll have to see. Maybe that can be a low that develops into the east coast and be a nor'easter. Also a signal on the GFS. Much more cold air in place on the GFS. Then this is our fantasy system. This piece of energy phases with this piece of energy. You can't really see it, but there's a piece of energy right here, and they sort of go up the coast. This one comes like it's not good, like that kind of. You can sort of see it. Track I drew, and we get decent 1 to 3, 2 to 4 inch event. It's more of a 3 to 5 inch event through many areas. Pretty good cold air in place. Again, I don't think it's going to happen. It's probably fantasy. 300 hours out. Even the euro isn't great. So we'll have to see what happens. Then we get another clipper potentially coming in. So that's the European model. Now I have to go with the European AI model. I'm just going to do the heights on the European AI model because it doesn't really show precipitation. Actually, I'll do heights and temperature. So again, very similar positive EPO pattern. Get a developing negative NAO, also developing negative EPO, just like the other runs. That's going to force cold air dumps into the continental U.S. Just like the European model, it really keeps this negative NAO hanging around. You can see it's not trying to get rid of that like the GFS. The problem I have with it is this persistent positive EPO, and that's not good for cold air into the U.S. This negative NAO could force some cold air, especially in the eastern U.S., but that doesn't look like that's not a great look. As you enter the model run, you got positive PNA, Gulf of Alaska low, Western Canada ridge, negative NAO. So this is prime for cold air in the east. This is also prime for snowstorms. It's a very good look to end the run. The overall run isn't great for cold and snow in the east, but to end the run, it's pretty good. Now, the 2-meter temperature map, again, similar. You get that cold that kind of hangs on here, the East Coast. That warms up eventually. First cold air dump is out west. It's quite transient though, and we get this Arctic air that starts to build and it starts to get released. And this looks like it has a lot of potential, but it weakens out quite a bit. It's probably due to positive EPO, not or the negative EPO not developing and not allowing this Arctic air to be forced south and east. And much weaker when it gets forced south and east. So we'll have to see. Interesting solution from the European AI model. Certainly not warm by any stretch of the imagination, but it could be a lot colder if you have that EPO cooperating. But we'll have to see what happens. Anyway, let's see AI model. So this is the ensemble. So this takes into account 50 to 25, 30 members on the GFS, 50 members on the European. So this is the ensemble. So GFS ensemble, very similar for the first part. But what's important is that it doesn't kill the negative NAO, so it keeps this negative NAO in place. It's not going to be as pronounced on an ensemble because it's an ensemble, so it takes the average. You can see higher heights near Greenland. It also keeps the positive EPO in place, so this is important. The operationals don't look great. They look good. They don't look crazy though. They showed a couple of fantasy runs, but it's good that they're showing a double high latitude block over Alaska and Greenland, and it's going to force cold air into the U.S. And you can see lower heights over the eastern U.S. So that's good stuff from the GFS ensemble. Also, this Gulf of Alaska low is a positive PNA, and you can see that developing. So good stuff. This might be too dry. This looks a bit dry based on the trough axis. Could favor out to sea, but we'll have to see. You never know. It's far out, but good look from the ensembles. And if we take a look here at our precipitation, or not our I want 12Z. If you take a look here at our 2-meter temperature anomaly, you can see again cold air hangs on for the east, or the east coast at least. Warm up eventually. First cold air dump is out west, but it's quite transient, and we get a cold air dump in the southeast, but more cold air on its way, and pretty chilly even on the ensembles. When you have temperatures 10 to 15 degrees below average on the ensembles, that should show you that there's pretty fair model agreement, um, model consensus even, that there's going to be a colder start, or not a colder start, a colder period, a colder time period. That's a GFS ensemble. Now the European ensemble looks very different. You can see it ends with a positive PNA, negative EPO. No, it's not negative EPO, it's a positive EPO, but also positive PNA, negative NAO. Let me take you through it here and see positive PNA, negative NAO. This decaying of the EPO could be a concern, but again, we have positive PNA, negative NAO. It's going to be very hard to get warm air intrusions in the east. So that's the European ensemble. And then the 2-meter temperature map. You can see cold air hangs on, a bit of a warm up, and then we get our cold air. Again, when it's this far below normal on an ensemble, let's just show that there's pretty good model agreement. And warm air moving east is a bit concerning. There's really no cold air. I guess there's a bit of cold air here, but that's a bit concerning. I'm not gonna lie. That warm air moving east, but we'll have to see. It could weaken. There could be another cold air dump, but we'll have to see what happens in the future.